The authority having jurisdiction, or OJ, may require a neutral conductor in all switch boxes based on local regulations or the National Electrical Code, known as the NEC. The NEC requires a neutral conductor in switch boxes for several key reasons. Firstly, safety is paramount. The neutral conductor provides a safe path for current to return to the electrical panel, effectively preventing electrical shock hazards. Secondly, control of lighting plays a role. In some lighting circuits, particularly those involving three-way switches, a neutral conductor becomes necessary to control the lights from multiple switch locations. Thirdly, line voltage compatibility is crucial. Many modern electrical devices, such as dimmers and electronic switches, require a neutral conductor to operate correctly and consistently. However, there are certain exceptions where a neutral conductor might not be strictly required in switchboxes. One such exception is single-pole switches. Single-pole switches that solely control the power to a single light or device typically do not mandate a neutral conductor. Another exception can be found in isolated switches. Switches located in isolated areas, such as detached outdoor sheds or garages, may not require a neutral conductor if there are no other electrical devices or lighting fixtures present in the immediate area. To ensure full compliance with the AHJ requirements and to future-proof your electrical installations, it is generally advisable to include a neutral conductor in all switch boxes, even if it is not explicitly mandated by the NEC for every situation. This proactive approach provides enhanced flexibility for future electrical upgrades and ensures the long-term safety and reliability of the entire electrical system. When dealing with electrical installations, always consult the latest edition of the National Electrical Code and any applicable local amendments. The NEC is a comprehensive set of standards designed to ensure electrical safety. Article 200 covers the use and identification of grounded conductors, including neutral conductors. Article 210 addresses branch circuits, which are the circuits that extend from the panel board to the points of utilization. Article 300 provides general requirements for wiring methods and materials. Article 314 focuses on outlet boxes, device boxes, and conduit bodies. Article 404 covers switches and their installation. The NEC is organized into chapters, articles, and sections, providing a structured framework for understanding and applying electrical codes. Be aware of specific requirements related to conductor sizing, grounding, and overcurrent protection. Section 310.15 provides guidelines for determining conductor ampacity. Section 250.4 outlines general requirements for grounding and bonding. Section 240.4 addresses the protection of conductors against overcurrent. Local amendments to the NEC can vary depending on the jurisdiction. These amendments may reflect specific regional conditions or local interpretations of the NEC. It is essential to consult with the local authority having jurisdiction to determine if any local amendments apply to your project. The AHJ is responsible for enforcing electrical codes and regulations. They can provide guidance on specific requirements and interpretations. They can also conduct inspections to ensure compliance with the code. Common electrical components used in switch boxes include conductors, switches, connectors, and boxes. Conductors are the wires that carry electrical current. Switches are used to control the flow of electricity. Connectors are used to join conductors together. Boxes are used to enclose and protect electrical components. There are various types of conductors available, including copper and aluminum. Copper conductors are more conductive and corrosion-resistant than aluminum conductors. However, aluminum conductors are lighter and less expensive. The size of the conductor required depends on the ampacity of the circuit. Section 310.15 of the NEC provides guidelines for determining conductor ampacity. Switches are available in different types, including single-pole, double-pole, three-way, and four-way switches. Single-pole switches control a single circuit from one location. Double-pole switches control two circuits from one location. Three-way switches control a single circuit from two locations. Four-way switches are used in conjunction with three-way switches to control a single circuit from three or more locations. Connectors are available in different types, including wire nuts, crimp connectors, and push-in connectors. Wire nuts are used to join two or more conductors together. Crimp connectors are used to join conductors together by crimping them. Push-in connectors are used to join conductors together by inserting them into the connector. Boxes are available in different materials, including metal and plastic. Metal boxes are more durable and can provide better grounding. Plastic boxes are less expensive and non-conductive. The size of the box required depends on the number of conductors and devices in the box. Section 314.16 of the NEC provides guidelines for determining box fill. When installing a neutral conductor and switch box, it is important to follow proper wiring techniques. Firstly, ensure that the power is turned off to the circuit before working on any electrical components. Secondly, use the correct size and type of conductor for the application. Thirdly, properly ground the neutral conductor to the grounding system. Fourthly, make sure all connections are tight and secure. Fifthly, carefully inspect the wiring before turning the power back on. Common mistakes to avoid when installing a neutral conductor in a switch box include using the wrong size conductor, not properly grounding the neutral conductor, making loose connections, and overcrowding the box. Using the wrong size conductor can lead to overheating and fire hazards. Not properly grounding the neutral conductor can create a shock hazard. Making loose connections can cause arcing and voltage drops. Overcrowding the box can damage conductors and devices. When troubleshooting electrical problems in switch boxes, it is important to follow a systematic approach. Firstly, identify the problem. Secondly, gather information about the circuit. Thirdly, use appropriate test equipment to diagnose the problem. Fourthly, repair or replace any faulty components. Fifthly, test the circuit to ensure that it is working properly. Common electrical problems in switch boxes include open circuits, short circuits, and ground faults. Open circuits occur when there is a break in the circuit. Short circuits occur when there is an unintended connection between two conductors. Ground faults occur when there is an unintended connection between a conductor and ground. Using a multimeter is essential for troubleshooting electrical problems. A multimeter can measure voltage, current, and resistance. To measure voltage, connect the multimeter in parallel with the circuit. To measure current, connect the multimeter in series with the circuit. To measure resistance, disconnect the power from the circuit and connect the multimeter across the component being tested. When working with electricity, it is important to take safety precautions. Firstly, always turn off the power to the circuit before working on any electrical components. Secondly, wear appropriate personal protective equipment, such as safety glasses and gloves. Thirdly, use insulated tools. Fourthly, never work in wet or damp conditions. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician. The National Electrical Code is updated every 3 years. It is important to stay up to date with the latest edition of the NEC to ensure that your electrical installations are safe and compliant. Changes to the NEC can affect requirements for neutral conductors and switch boxes. For example, recent changes have focused on arc fault circuit interrupters, RFCIs, and ground fault circuit interrupters, or GFCIs, which may indirectly impact neutral conductor requirements. It is important to understand the relationship between neutral conductors, FCIs, and GFCIs. FCIs are designed to protect against arc faults, which are dangerous electrical conditions that can cause fires. GFCIs are designed to protect against ground faults, which are electrical conditions that can cause electric shock. Both FCIs and GFCIs rely on the neutral conductor to function properly. Section 210.12 of the NEC specifies requirements for FCIs. Section 210.8 of the NEC specifies requirements for GFCIs. Understanding these requirements is essential for ensuring electrical safety. In summary, a neutral conductor is often required in switch boxes for safety, lighting control, and device compatibility. There are exceptions for single-pole switches and isolated switches. Always consult the NEC and local AHJ requirements. Follow proper wiring techniques and avoid common mistakes. Use a multimeter for troubleshooting and take safety precautions when working with electricity. Stay up to date with the latest edition of the NEC.